Hello learners, welcome to this course on practical machine learning using Google Colab. So in this tutorial, I will be describing about an handwritten digit recognition using k nearest neighbor classifier. So I strongly recommend the viewers to look at my earlier video on the fundamentals of k nearest neighbor classifier before progressing into this tutorial. So an MNIST data set is a handwritten digit recognition. So here if you see the MNIST data set, it contains the handwritten digits like this from 0 to digit 9. So it has about some 10 classes where each image contains a digit and it is of grayscale in nature. So it has a pixel value varying from 0 to 255. The size of each image, is about 28 by 28. So 28 pixels along the row and 28 pixels along the column. And it's a grayscale image. And this MNIST data set, it contains about 60,000 training images and 10,000 test images are available. So we make use of this MNIST data set for learning our k nearest neighbor classifier. So we will be using this data set to categorize the digits by using a k nearest neighbor classifier. So let us go on to this program by opening the Google Colab environment. So here I will set the notebook settings. Go to Edit, Notebook Settings. So let me make use of a GPU. And let us start our program by connecting it to the cloud environment. Let it get connected to the cloud environment. So once it gets connected, you will get this connected. Right. So now it is connected to the cloud environment. First step which we need to do is we need to import the packages required for this program to work. So I am going to import the print function because we might be requiring the print function to print some parameters. Then I am going to use a sklearn. This is a machine learning package. So this sklearn, it contains lot of machine learning libraries are available. So we are going to make use of this sklearn package, in which I am going to have a function called as train test split, which is used for splitting your data into training and test data, as well as for training data can be split up into training and validation data. So for that we make use of this train test split function. Again from sklearn package, we have a class called as k neighbors classifier, which will be performing your k nearest neighbor classification process. Then sklearn, it also contains a classification report where I can see the performance metrics like precision, recall, F1 score, etc. Then from Keras is an advanced machine learning package which contains different data sets. So for example, if I go into Google and type Keras data sets, it opens this link. Here you can find different data sets are available in Keras library. MNIST data set, CIFAR 10, CIFAR 100, IMDb movie review, Reuters New Wire, Fashion MNIST, Boston housing price regression data set. So like that we have some number of data sets are available in the Keras package. So we are going to make use of this MNIST data set for our process. So we use from Keras, try to import the MNIST data set, and the labels of this MNIST data set will be in terms of a 0 to 9. So we need to convert this label into a vector. So for that we use a procedure called as one-hot encoding method in order to do the one-hot encoding method, we make use of the utils. From the gas package, import the NP utils. Then we are going to use the NumPy library, which is a numerical Python library mainly used for array and matrix computation, and in short form we are going to use it as NP in our code. And we will be making use of some computer vision library packages also. So we import all the necessary functions which we require for our program. So execute the cell. Then let us go and load the data set. So the first step is, from the Keras library, I need to load the data into our program. So for that I make use of MNIST.load_data function. So which loads the data into this output variables, where xtrain is the training data and ytrain is the training data labels. Same way, xtest is the test data and ytest is the test data labels. So this xtrain and ytrain contains 60,000 samples data along with labels. Same way, xtest and ytest contains 10,000 data along with its labels. So those get loaded into our program. It gets downloaded. Once it is downloaded, we need to reshape it. So in order to do reshaping, I am going to find the characteristics of the image by using .shape function. So .shape of 1 gives me the width information, .shape of 2 gives me the height information. So which is the height of the image and width of the image is found. So xtrain is the training data. So I find the training data's width as well as the height. So we know the width and height is nothing but 28 by 28. So when I multiply 28 by 28, I get 784. So 784 is assigned to the number underscore pixel. Then I try to reshape it, reshape the vector. Using xtrain is the training data, I am going to reshape. So I say it is, I am going to have some .shape of 0 will give me the number of samples in the data set. For training data, I have about 60,000 data. So we have 60,000, 784. So I reshape the matrix in terms of the first sample, 784 elements. Second sample, 784 elements. Third sample, 784 elements. So like that it goes on till 60,000th sample, 784 element. So where the 784 element is nothing but the pixel values of the image. Same process we do it for test data also. So here I take the .shape of 0 gives me 10,000 test data and 784, which means again first data 784 elements, second data 784 elements, it goes on till 10,000th sample 784 elements. Then we try to print the training data shape of 0, and when we visualize it, we get about 60,000 because .shape of 0 will give me the number of samples in our list. Now, once we have done reshaping our data, we can normalize our data because our image contains a pixel value between 0 to 255 since it is a grayscale image. So we can convert this pixel values from 0 to 255 to 0 to 1. So by doing the xtrain divided by 255, 255 is the maximum value of my pixel. So we can change the range of pixel values from 0 to 255 to 0 to 1. So we do it for both the training data and test data. So we try to normalize the data so that the pixel values lie between 0 to 1. Next step in our program is we have labels associated with each and every data. So this label, for example, the first image might be a digit 2. So the label will be 2. Same way the fifth image might be 9 and the label will be 9. So we need to convert this label into a vector form. So it will be easy for us to do the classification part. So in order to do that, we perform one-hot encoding method. So one-hot encoding is a very simple method where I convert a label into a vector. So for example, if the image contains digit 1, then I use a vector element for each class. So the first element is for class digit 0, second element is for digit 1, third element is for digit 2, digit 3, digit 4, digit 5, digit 6, digit 7, digit 8, digit 9. So for each class, I have an element in my vector. So depending upon what type of label it is for an image, I assign 1 to that position. So here in case of a digit 1, I place 1 at this position because this position represents the class 1 or digit 1. Same way, if my image contains digit 7, it comes at this position. So 0, 1, 2, 3, 4, 5, 6, 7. So 7th position, we try to put a 1. For all the other labels, we put it as 0. So this process is called as a one-hot encoding process. So to formulate this, we make use of this np_utils function to change it to be in this vector form. So we do it both for your training labels as well as for testing labels. So we convert our label into a one-hot encoded vectors. So again, here when we see this yTrain and yTest, which is now a vector form of the labels. So the dot shape of 0 will give me the number of samples. Dot shape of 1 will give me this width information. So width contains 10 classes. So the 10 classes, I try to take it into this variable num_classes. So yTest dot shape of 1 will give me the width information. So it represents the number of classes. If the width is say some 20 elements, then the number of class will be 20. If the width is some 5 elements, then the number of class will be 5. In our case, our width is 10 elements, so the number of classes will be 10. So I try to print it and see how many classes are there in our data set. So it says we have 10 classes. Then we start our process of machine learning. So when we obtain the data set itself, we get a separate training data and test data. So we need not worry about splitting a data into training and test data. But we have in k nearest neighbor classifier, we have some parameters to be tuned. Something like a k value needs to be tuned, or the distance metric can be tuned. So in order to do that, we need to divide our training data into training data and validation data. So for that, what we do is we make use of this train test split function. We give the training data along with the training labels and specify the split up ratio. So I want 10% to be split up from this training data. And this 10% will be used for your validation or for estimating the parameters of your classifier. So in order to have a reproducibility in our result, we make use of this random state to be some value. So usually this value should be greater than 40. So once I do this split up, I get training data and its training labels. Same way validation data with validation labels. So where this validation data and validation labels is the 10% of your original training data. So then we print this data and see how many data is available in training category, how many data is available for validation category, how many data is available for test category. So when I print it and see, you can see initially we had a training data of about 60,000 and test data of about 10,000. So the test data remains same, whereas the training data 60,000 we have divided into 54,000 for training and 6,000 for validation. So this validation data is important to identify which parameter gives me the best result, best performance metrics. So once this is done, let me initialize the k value. So I am going to take k value in the range of 1 to 10 with an incrementation of 2. So k value, I am going to take it as 1, 3, 5, 7 and 9. So remember in Python, so the stop index will not be included for your computation. So it will go just before your stop index. So we start with 1 and end with 10, which means it will go before 10. So the before 10, the legal value is your 9. So it will compute for 9 till 9. So we are going to assign this k values in this kvals library. And in order to append the accuracies for each k value, I am creating a list. Right now it is an empty list. Then we go and change the k value and see our performance on the validation data. So first let me use the for loop. In k changes from 1 to 10 with an incrementation of 2. So first k value takes to be 1 and I am going to use that k value for initializing our k neighbors classifier. We create a model. Then once the model is created for k value 1, then I am going to do the training process. So training process is done by using this model.fit function. So I give both training data and training labels for the training purpose. Once model gets trained, I need to validate it. Right? With the k value 1, I need to see what is the performance metrics. So for that, I use a function called as model.score. I provide validation data and validation labels. Obtain the score. Then append that score to the accuracy list. So when the for loop runs for the first time, I will get k value equal to 1 and whatever accuracy we got, it will be appended. When the k value runs for the second time, my k value will be 3 and whatever accuracy I get, I will get appended to the accuracy list. Same way for k5, accuracy will be appended, k7 accuracy will be appended and k9 accuracy will be appended. So we have created a list. So in this list, we need to find which k value gave me a better performance metrics, better accuracy. So in order to do that, we use this np.argumentMax function to find which index gave me or which k value gave me highest accuracy. So that index I try to take it here. I try to compute here. So here you see right now the code is running. For k value 1, we have obtained an accuracy of about 97.48%. Same way it will be computed for k value 3, 5, 7 and 9. So for k value 3 also we got a similar accuracy of 97.48%. So like that it will be listed till k value 9. Once it is done, we use this np.argumax function to find which index gave me the highest accuracy. Then obtain the k value for which we got a highest accuracy and retrain the model with that k value. So k value equal to 5, you can see the accuracy got little bit reduced, 97.12%. For k value 7, it still got reduced, 96.77%. Let us wait for some more time so that the k value will come to 9. So here you can see k value 9, it is still more reduced. So we can find that either I can use a k value of 1 or 3. Both have resulted in a similar accuracy. So we will find the index 0 and 1, which has a k value of 1 and 3 to be having the highest accuracy. So either I can use the index 0 or 1 for retraining the model. So we find the k value with the highest accuracy. So k equal to 1 achieve the highest accuracy of 97.48% on test data. So now we use this k value for retraining our model. So again, let me initialize the model with the k value which got the highest accuracy. Once model is created, we again do the retraining process on the training data and training labels. Once it is done, we can expose the model to a test data. So to expose a model to the test data, I use the function called as model.predict. Here I specify only the test data. Then the predictions are updated here. Once the predictions are obtained, we can print the data by using the classification report. So classification report, it will take both the ground truth value. So y test is the ground truth value of the test data and the prediction is from our machine. So we can make use of these two data to see the performance metrics like precision, recall, F1 score, etc. So now let us print the classification report. Here you can see the digit wise the performance metrics. For digit 0, the precision is about 0.98, recall is about 0.99, F1 score is about 0.98. Same way for each digit, an individual performance metrics is obtained, and also we can see the average value of each performance metrics. Where this support indicates the number of images containing digit 0 in the test data. So for example, 980 images are there in the test data with digit 0. Same way 1028 images are there in the test data with digit 7. So like that, out of 10,000 images, each category contains this many number of images. So that is what it is represented by the support functionality. So this is how a classification can be done using a k nearest neighbor classifier. Thanks for watching. Please subscribe for more technical learning. Thank you.